What's up, everybody, and welcome back to another video on SAT Math. Now, this video is a sequel to a previous video I made on how to get an 800 on the math portion of the SAT. That one was 13 strategies, and this one is 14 strategies. When you look at these topics in total, they constitute nearly 31% of all the content covered on the SAT. By the way, if you're wondering who I am, my name is Huzefa. I'm the founder of Scalar Learning and an SAT expert. I particularly specialize on the math portion, and if you want to see the research and analysis that went into coming up with these strategies and making these videos, I highly recommend checking out the first video in this series. Without further ado, let's jump in to the 14 strategies to help you nail a perfect 800 on the SAT Math. The first category is linear function word problems, which constitutes 2.93% of the entire exam. In this one, the strategy is no slope versus y-intercept, and I mean that on a conceptual level. Y-intercepts are usually your starting or initial values. Slopes are all about rates of change. So when we know that, we're much better equipped to answer these questions in general. Now let's dive into the particulars of this one. We get this first equation. Of course, this is a nice linear equation, just we don't have x and y, but we have h and l as our variables. It says the formula above can be used to approximate the height h in inches of an adult male based on the length L in inches of his femur. What is the meaning of 1.88 in this context? So immediately I know that 1.88, is it the slope or is it the y-intercept? It's the slope because it's paired with that variable. So we're talking about a rate of change relative to that height. And so we're going to go through these ones. It says the approximate femur length in inches for a man with a height of 32.01 inches. We can immediately debunk that. If I plug in 32.01 for the height, these guys would cancel out and I'd get a value of 0 for L. So it doesn't actually make sense, so goodbye A. The approximate increase in a man's femur length in inches for each increase of 32.01 inches in his height. Now again, we're talking about rate of change, but they're referencing the y-intercept. They're referencing that initial value. That doesn't make any sense either, so we can dismiss that. Now it says the approximate increase in a man's femur in inches for each 1 inch increase of his height. That sounds a little bit better. The problem is, if we really look at what's happening here, if I increase the L value by 1, that's what's going to make the height go up by 1.88. And we can quickly see, like if I plug in 0 for L, I get 32.01. If I plug in 1 for L, it would be 1.88 plus 32.01, which means that the length increases by 1 inch, the height goes up by 1.88, which means our answer is D. The increase in a man's height in inches for each 1 inch increase in his femur length, which represents L, and there it is. The next category is manipulating quadratic and exponential expressions, which constitutes 2.93% again. And here the strategy is recognize vertex form versus intercept form, in particular with quadratics. So what am I talking about here? Well, if we look at this function, this is of course a quadratic function, right? And we're seeing it in intercept form. What does that mean? That means that I can quickly identify the x-intercepts as -6 and +4 just from looking at it in this format. So then it says, which of the following is an equivalent form of the function above where the minimum value of f appears as a constant or a coefficient? So again, what does this mean? This means that I should be able to look at this and immediately see what's the minimum value. But it doesn't matter if they say minimum or maximum. Both are the vertex, means we want vertex form. So what is vertex form? Vertex form is y equals, there's an a, but I won't include it because there's not going to be an a value here. X minus h squared plus k, right? So that's our vertex form, and where hk is the vertex. So when I look down at these, I can immediately dismiss a and b because they're not in vertex form, right? So we know it's got to be one of these two. These look like they're in vertex form. Now, when solving this problem, the last thing we want to do is we want to say, well, which one of these is wrong? Now, if I quickly look at this, I know that if I were to FOIL it out, which I'm not going to do in full, but I know if I'm going to FOIL it out, my final term is going to be, the constant's going to be -24, right? Because it's going to be that 6 times -4. Well, which one of these are going to give me -24? If I FOIL this one out, I'm going to get x squared minus 2x plus 1. Add that 1 to -21 and I'll get -20. In this one, I'll get x squared plus 2x plus 1, right? And that 1 plus the negative 25 does give me that negative 24, which means D is my final answer. The next category is structure in expressions, which constitutes 2.76% of the math content. And the strategy here is to eliminate options using positives and negatives. So structure in expressions is really all about manipulating expressions, moving things around to get equivalent expressions. So if we look at this one, it says we've got a nice quadratic, x squared plus 6x plus 4. Which of the following is equivalent to this? Now I could go through and FOIL all these guys, or I could put this into vertex form. I'm gonna do neither. Instead, I'm gonna look through and I'm gonna say, well, these are all positive, right? So anything with minuses, I'm pretty much gonna dismiss. And I'm not talking about the minuses at the end, I'm talking about in here. The reason why is because if I were to FOIL these guys, for example, I'd get a negative 6x. Okay, so just having a good understanding of FOILing, I can already say, hey, C and D are gone based on that negative positive discrepancy. Now we come to A and B. You might be tempted to go with A because it's a plus and this is all pluses. But the key here is we should end with a constant value of 4. Well, this one is going to give you x squared plus 6x plus 9. When you add that to 5, you're going to get a 14. That's no good. Here we'll get x squared plus 6x plus 9 again, but then that 9 minus 5 does give you the 4, which is the same as up top, and we're good to go. The next category is operations with polynomials, which constitutes 2.59% of the math material. And here the strategy is binomials must be FOILed. You want to escape that trick, that trap where you just say, oh, it's a squared plus b over 2 squared, right? Where you just kind of, oh, I can just distribute the exponents. That doesn't happen when there's a plus there. This is wrong. So we immediately know that 2 terms is not what's supposed to happen. We're supposed to FOIL this, which means it's supposed to be set up like this. A plus b over 2 times a plus b over 2. And then if I were to FOIL this out, I'm going to get a squared plus ab over 2, right? FOIL, FOIL. Plus again ab over 2, and then plus b squared over 4. And before doing anything else, I can look at the final terms and say this is a b squared over 4, this is a b squared over 2, this guy is out, and D is the one. Category number 5 is center, spread, and shape of distributions, which constitutes, again, 2.59%. And the strategy here is to know the formula to calculate mean. So what is that formula? Well, again, to calculate mean, it's my total over the number of terms equals the mean. So now let's put that into play. It says the mean score of 8 players in a basketball game was 14.5 points. So we don't know the total. We know that there's 8 people, 8 players, and that mean equals 14.5. So I'm going to throw that there. Then it says if the highest individual score is removed, the mean score of the remaining 7 players becomes 12. Well, first of all, to process that second part, I need to know the total, but I've already got this nice setup here. Multiply both sides by 8, and I get x equals 116. Now I plug that into a new equation. I say if we remove my highest score, I'm going to use x. Actually, let's change it up. I'm going to use y for my highest score. If I remove the highest score, the new average now out of 7 players, so now it's divided by 7, equals 12. What is the highest score? Meaning what is that value of y? Now we just isolate. Multiply both sides by 7, I get 116, minus y equals 84. Subtract 116 from both sides. And I get, I'm going to bring it up here, it'll be negative y equals negative 32, or y equals 32, and that's it. The next category is quadratic and exponential word problems, which constitutes 2.07%, and the strategy here is memorize the formula for exponential growth and decay. And what is that formula right off the bat? Normally I would use a. I'm going to use a different variable because they use a in this equation. I'm going to say b times 1 plus or minus r, which stands for the rate that it's growing, rate at which it's growing in a percentage, but in decimal format, to the t power. T is the time that's elapsed, usually years. So now let's read this question. It says Juan purchased an antique that had a value of 200 at the time of purchase. That's my initial value. So B is 200. Each year the value of the antique is estimated to increase. That means we're using the plus, not the minus. 1 plus 10%. in decimal format is 0.1 to the t power. It's growing by every year, whatever. And they said the estimated value of the antique 2 years after purchase, where t would be 2, can be represented by the expression 200a, where a is a constant. What is the value of a? Now we just finalize this expression. 200 times 1 plus 0.1 is 1.1 squared, because it's to 2 years, equals 200a, and then we solve for a. So I'm going to divide both sides by 200, boom. A equals 1.1 squared, and 1.1 squared is, of course, 1.21, which is the same as 11 squared is 121, right? So it's 1.21, and that's it. The next category on the list is linear and quadratic systems, which makes up 2.07% of the math content. And here the tip is very simple: just substitute and factor. And I love this category, by the way. So let's go ahead and check it out. It says the graph of the function f defined by this function, this quadratic, is shown. If the function g equals this nice linear function, what is a possible value of a such that f of a equals g of a? Translation, we're trying to find where these guys intersect, and what is that x value where they intersect. It's a little tricky because they mix in some function notation, but that's all they're saying. Where do these functions equal each other? For what value of x do they equal each other? Now, quick caveat. Because they give you a graph, this one can be solved graphically if you want to do it that way, and it is a little faster. But I want you to have a tip in your mind that whenever you panic or you're not sure what to do, you go into autopilot mode. And the autopilot mode, the default should be to set these functions equal and solve. So I'll do it that way. So first I'm going to say negative x plus 10 equals negative 1/2 x plus x minus 4 squared. Make the most of this room here. Plus 10. Okay, so again on the test we're also going to have limited room, so this is just like the real thing. So first I'm going to get rid of both these 10s, just cross them off. Then I have negative x equals negative 1/2 x minus 4 squared. I don't want to deal with a fraction, so I'm going to multiply both sides by negative 2 to get rid of that negative 1/2, and I get 2x equals x minus 4 squared. It's already looking a lot better. Now I'm going to FOIL this left side here. So I have 2x equals x squared minus 4x minus 4x, which is minus 8x. Remember, I'm foiling, plus 16. Now I'm going to subtract 2x from both sides, set it equal to 0. It's just going to write on the graph. Let's write over here. We got 0 equals x squared minus 10x, so I'm subtracting that 2x, plus 16. And last but not least, let's FOIL, or factor, excuse me. Oops, 0 equals x minus 8x minus 2, right? Why did I choose those values? They multiply to positive 16, add to negative 10, so my two solutions are positive 8 and positive 2, and I can choose either of those. It's a free response, we'll go with 2. Now I'm going to show you how to do it graphically if you wanted to. Because they give you that nice linear function, all you have to do is say, hey, it's got a y-intercept of 10, it's got a slope of negative 1. Now just watch how this graph is laid out. It goes 1 across is two jumps, 1 down is 1 jump. So slope of negative 1 is actually like this. Whoops. Boom, it's reasonably good drawing there. And we can see our intersections do indeed occur at 2 and 8. The next category is function notation, which constitutes 2.07% of the material. And here the tip is replace and simplify. Very short, brief, concise tip, but it really works. And function notation, you just got to understand what's going on here. And what they're doing is they're saying, here's my function, and what I'm plugging in for x is negative 3x. So what that means is wherever I see an x in this equation, I'm going to replace it with negative 3x. That 5 is still good. Multiply, that becomes positive 6x plus 5, and that's it. Your answer here is B. Next on the list is congruence and similarity, which makes up 2.07%. And the strategy here is fill in missing dimensions. Look, with these geometry problems, you want to recognize it's just a big puzzle, and you got to put the pieces into place to figure out what's missing, to figure out the answer. So I'm going to do that methodically, step by step. So first, we're gonna go to this fact that, hey, we have y equals 75. Okay, so we got two isosceles triangles. It says y equals 75. Immediately, I'm throwing that in my diagram. I'm even gonna mark these angles as congruent, even though I don't need those. That's just my instinct. I'm gonna mark them as congruent. I'm gonna mark these guys as congruent, because I know that that has to be true. But then it gives me this really nice equation. Let's come back to the equation and plug and chug. So I know that y equals 75. That means 180 minus z equals 2 times 75, which is 150. Subtract 180 from both sides, and I get negative z equals negative 30. Well, look at that. We know that z equals 30. Now I'm going to write that into my diagram. So there's 30 degrees for z. Well, wait a minute. If these two angles are congruent, and all the angles in this triangle have to add up to 180. Now I'm seeing that trend, so I know that these two guys right here must be 75, right? 75 plus 75 plus 30 gives me 180. Last but not least, now it's in the diagram, I can see that these angles are sup, right? Because they make an entire line, so if two angles make a linear pair, they are supplementary. It means they also add up to 180. So what plus 75 is 180? 105 degrees, and that's it. Next, we have one of my favorite categories to teach, which is isolating quantities. This makes up 1.9% of the test. And I love teaching this because my advice is so simple, and it is skip the nonsense. Okay, what do I mean? These types of questions are infamous for having a bunch of information to confuse you intentionally that is not relevant to solving the problem. How do you identify these? Isolating quantities can be identified really easily when you look at the answer choices. So they have some formula, and you'll notice in every answer choice, they've got some variable equals blah, 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 okay? And they'll also say, what is W in terms of A, or something like that, depending on what the variables are. All they want you to do is isolate, isolate, isolate. That's it. So I don't care what Current's formula is. I don't care what Musteller's formula is, however you pronounce it. I don't need to know the intricacies of the variables. All I need to do is say, hey, they're talking about Current's formula. Okay, I know I'm here. What is W in terms of A, aka isolate W. So I'm going to do that. So first, I'm going to multiply both sides by 30. And I get 30a equals 4 plus w. Then I'm going to subtract 4 from both sides. 30a minus 4 equals w. And that's it. We're done. The next category is table data, which makes up 1.9% of the material. And here the tip is know your universe. What am I talking about? I'm talking about probability. Probability is the number of favorable outcomes over the total universe of outcomes. And the total universe is always relative to how the question is being asked. For example, I might want to know the probability of something occurring at a school, or I might want to know the probability of that same occurrence within a particular classroom. That shrinks the total universe. So it's the same thing here. And the key thing to look out for is usually near right where the specific question is being asked, which is down here. It says, which of the following is closest to the probability that a right-handed student selected at random is female, which means my universe is going to be the right-handed world. For my final answer, I'm not going to care about left-handed people, which means that the amount for the total universe is 122. That's a huge help right there. Okay, now we have to actually go through this question, which is a pretty difficult problem. So first it says there are 5 times as many right-handed female students as there are left-handed female students, which means I could represent the female as 5x. The right hand is 5x, the left is x, right? That's a 5-time difference. Then I say there's 9 times as many right-handed males as there are left-handed males. So now that's 9 times that guy. This is great because I can set up a system of equations and figure out what x and y equal. So my system of equations is going to be, let's see if I can make the room here, x plus y equals my total of 18. And then I've got 5x plus 9y equals 122. So it's a little tight on space. We're doing our best here, just like you'd have to on the real test. Now I'm going to use my elimination. I'm going to multiply the top one by -5. I get -5x minus 5y equals -90. Oof, squeeze that in there. These guys cancel out. 9y minus 5y is 4y equals 122 minus 90 is 32. Divide both sides by 4. Y equals 8. And if I know y equals 8, I can plug it into that top equation, x equals 10. And check this out, this is great. Now I plug these guys in here, and I know the right-handed, which is all we care about, right-handed for females must be 5 times 10, which is 50. And for males, it's 9 times 8, right, for that y value, which is 72. But what did I want? I wanted the probability that a right-handed person out of the 122 space is female. The female is 50, and that's gonna give me my fraction for the probability. This is a calculator problem, so plug that into your calculator and you will get, rounded to the nearest thousand, 0.410. The next category is scatter plots, which constitutes 1.9% of the test. And here the strategy is line of best fit trumps dot. Now, why do I put this out there so emphatically? The thing is that we always want to believe that a real data point is better than something on a line of best fit, which is an approximation and our way to predict outcomes. But the reality is, you want to look at what the question is specifically asking. If they're saying we want you to use the line of best fit, don't get fooled by one of these real data points. So for example here, when we read this guy, it's talking about we're trying to find this leaf litter mass remaining after at a certain temperature, okay? Decomposing for 3 years. None of this is really that critical, but in terms of the problem, it's just sort of background information. Then it says, a particular forest in Canada whose data is not included had a mean annual temperature of -2. First of all, where's -2 on this? This is -5, that's -2.5, here's my -2, right? Based on the line of best fit, which is closest to the predicted percent remaining. Well, let's go ahead and see. We'll use a straight line tool just to make it really nice and straight, exact. You don't need that, of course. And look where it intersects the line of best fit. It intersects it perfectly at 70. Now, if you were not careful, you might have chosen this. Look at that data point. It looks close enough to 2 years. So you might have said, oh, maybe it's 82%, right? Because they have a value there for 82%. But don't be fooled. Stick to the line of best fit, and you're gonna be good to go. Next, we have linear and exponential growth, which constitutes, again, 1.9% of the test material. And here the tip is to distinguish between adding and multiplying. Linear growth is all about adding a common difference over and over. So for example, linear growth would be 5, 10, 15, 20, 25, and so on. Exponential growth is about having a common multiplying factor. So for example, it'd be 2, 4, 8, 16, 32, that's doubling, right? In this question, we're trying to just identify the type of growth, whether it's linear or exponential. Well, this is all jumping sequentially, right? 0, 5, 10, 15, 20. That's fine for the x value, but we're looking at the y value, and usually x is time. We're looking at the y value. Here it's increasing by a multiplier. It's going up by a multiple of 10 every time. 10 times 100 is 1,000. 10 times 1,000 is 10,000. 10 times 10,000 is 100,000. Therefore, this is not linear and this is not decay. This is exponential growth. Last but not least, we come to radical and rational equations, which makes up 1.72% of the test material. And here the strategy is when solving for exponents, get the same base. A problem like this is very, very difficult. It's one of the harder exponent questions I've seen. So we look at this and what is the value of a to the x over 2y? And you might even be tempted to go with d, but you want to go to your wheelhouse, especially in a problem like this where you might be confused, and just say, I want same base. Now, 8 and 2 are similar because 8 can be represented as 2 with an exponent, and it can be represented as follows. 8 is simply 2 to the third power. And so I'm just replacing that 8 with 2 to the third, keeping the x exponent, and then 2 to the y on the bottom. Then I'm going to use my exponent rules and multiply those, and I got 2 to the 3x over 2 to the y. All right, that's pretty good. Well, let's use some more exponent rules. I have the same base, and I can use the quotient rule, which says this equals 2, well, actually, let's write it up here so I have more room. This equals 2 to the 3x minus y, subtracting whatever's in the bottom. Now we see something that makes sense. Why did they give us this? Oh, 3x minus y can be replaced with 12, so it simply becomes 2 to the 12th. And check it out, 2 to the 12th is right here with option A. and we're done. That's it for these additional 14 strategies. I hope you enjoyed this video. And if you want to see more from the Scalar Learning channel, make sure to click that subscribe button. I wish you all the best of luck in achieving your goals for the SAT math portion. And I hope to see you in the next video. Take it easy.